Hello friends, in this video I will explain about the applications of diamond. I already explained the types of diamond in my previous video. Basically two types of diamond, natural diamond and synthetic diamond, and how we grow the synthetic diamond into the laboratory. I already explained it in my previous video, so I will put the link of the video into the description so you can have a look at that video. Next, one of the most important application of diamond is in the diamond jewelry. So we have the diamond ring, diamond necklace available in different colors. Again, the two types of diamond, natural diamond and lab grown diamond. It runs the biggest business in the world. And other than the jewelry applications, diamond also used for cutting tools and the drill because it is a hardest material. Next, so diamond detector. This is one of the important topic of my thesis. So I worked on diamond detector. So I will explain it. So there are four types of diamond: 1A, 1B, 2A, and 2B. You can see here 1A, 1B, 2A, and 2B. In 1A types of diamond, we have the impurities of nitrogen in the form of clusters, and 1B we have the nitrogen scattered all over the lattice, and 2A we don't have the impurities of nitrogen, and 2B we have the impurities of boron basically. So if we have the nitrogen in the diamond, then it reduces the charge collection efficiency, so it is not favorable for the detector applications, because you have the signal created, electron hole pairs created by the ionizing particle. Then this can be trapped if you have the impurity of nitrogen. So here in 2A types of diamond, we don't have the impurities of nitrogen, like we have very less impurities, 1 parts per billion. So 2A types of diamond is basically used for the detector applications, and the current applications of diamond is the one of the application is beam condition monitors. It is used as a beam condition monitors in the Atlas experiment, which is basically at CERN, Switzerland. And the this is used because it is radiation hard, because we don't have ionizing radiation damage in the case of diamond, and also non-ionizing radiation damage is smaller than the silicon. And the next application is the neutron detectors. So it can detect both thermal neutrons and fast neutrons. In the case of thermal neutrons, as we know, neutron interact with the, here we put a layer of lithium fluoride, and then it makes the nuclear reaction with the lithium, and then it produces the tritium and alpha and some energy. So we can detect either of the two, because it's in the back to back, either alpha will be detected or tritium will be detected inside the neutron, inside the diamond, which will basically detected by the electron hole pairs created by the basically either tritium or alpha. In the case of fast neutron, that neutron basically directly interact with the carbon and then produces alpha and beryllium, and then we can detect the alpha and beryllium inside the diamond. So this is the one of the most important application of the neutron as a neutron detector. So diamond is planned to be used in the ITER experiment, which is where we want to detect the neutrons at 300 degrees Celsius. Basically, you can see 300 degrees Celsius is very huge temperature, and I don't know any other material which can be used at 300 degrees Celsius, but here you can see you can use it diamond as 300 degrees Celsius because of the large band gap, basically 5.5 electron volt. Then the other applications of diamond is the diamond used in the dosimetry. You can also do the dosimetry, and then you can find the reference where people demonstrated diamond can be used as a dosimetry in the X-ray. And the issues with the diamond is currently is the one of the issue is the large cost. You have the diamond large cost, and the smaller size diamond basically is grown up to 1 by 1 centimeter square, and so you cannot make a large detector. If you want to use as a tracker, you cannot create a large layers of the trackers. And the different samples of diamonds basically show the different properties, so it's the problem of the reproducibility. So these are the problems. That's why diamond is not used as a tracker in the collider experiment, but we use like for example here it is used as a beam condition monitors, and then it is also planned in the ITER experiment where we run to detect the neutrons at a very high temperature. And diamond basically basically possesses a time resolutions of 100 picosecond as I seen in the references at 300 micrometer thickness. But now you know the silicon detectors is very advanced, and you can see that the algate detector that provides the time resolutions of tens of picosecond. So diamond cannot provide like tens of picosecond at present. Then the next important application of diamond is a diamond as a heat sink. As we know, diamond is an electrical insulator but possesses the largest thermal conductivity because of the highly ordered crystalline structure. It also has a strong covalent bonding and less phonon scattering because of the highly ordered crystalline structure. So diamond thermal conductivity is basically 2000 to 2200 watt per meter Kelvin, which is basically 5 times of the silver. If you check, the silver is 429 and the copper is 398. It is not a diamond, is not a metal, still it has the largest thermal conductivity. And you can determine the thermal conductivity by laser flash techniques. So I put the reference how it is determined. Basically we use a laser, and then we put we supply a short pulse at one end and then measure the time time required basically for the propagation across the next end, and then that is how we determine the thermal conductivity of the diamond. So diamond heat sink basically is used as a electronic heat sink. It's a basically new area of applications, and you can just see the specification of diamond heat sink. Basically it's a basically lab grown diamond by MPCVD process, and then you can check the other specifications, and you can see the follow this particular links. Okay. Then the next important application of diamond is in the spin based devices. Basically the impurities in the of the nitrogen into the diamond is very important basically in some of the areas. So the nitrogen in the diamond, basically this is the diamond structure, replaces the 2 carbon atoms. Here it replaces the 2 carbon atoms and it creates the 2 sides. One is the electrical neutral, another is the negatively charged because of the excess of the electrons. So one is the electrical neutral, another possesses the electron. Since we don't know the electron has the spin, so now you can these types of, if you have these types of material, you can, if you apply the electromagnetic radiation or magnetic field, it will the spin will respond basically due to the excess of the electron. So these types of vacancies in the diamond you can detect by using the photoluminescent spectroscopy, and these types of material is still finding an application in different areas, in many areas. So one of the area is optically detected magnetic resonance, where you can just change the spin by application of electromagnetic radiation or magnetic field. Another, these NV centers can also find the applications in quantum computing, where we need 2-level systems, basically qubits. And these spin, basically this property of the spin exists at room temperature, and this can be very useful in the quantum computer design. So this is one of the articles written in the Nature. You can read it about the applications of these NV centers in the diamond. So this is all. Thank you.